Good morning, students, and welcome to the Statistics and Mathematics Tutors course on Stochastic Processes. So, in today's video, we are going to start with Stochastic Processes 2 by looking at Kivin theory first. Okay, so stay tuned and let's get into the video. So, what is Kivin theory? What is it about? So, in daily practice, we mostly visit banks, we go to the saloon, barbering shop, and a whole lot of activities that we find ourselves in. And in these activities, we mostly find ourselves in queues or we join a queue and wait for some service. These are all queuing models. Why is it important? If you are doing a business, it is very important to know the number of customers you receive in a day, the average number of customers that you have so that you know the space available for these customers. Okay, the number of servers that you have is also very important. As in, if you have 1,000 customers a day to your company, there's no way one server can actually handle these people. If that is a human being that are actually serving these people, one person cannot serve these. So you need to know your audience or your customers so that you will know the number of servers and also at every point in time how many customers are supposed to be in the queue to be served so that some customers will not have to come and wait for so long, then lose patience and leave your service facility. If you do that, you are probably going to what? Collapse your business. And that is why queuing theory is very, very important. Okay? It's very important. So let's look at some examples. I've mentioned some already, like visiting a doctor, visiting a saloon or barber shop, visiting a bank. You can relate to other examples that you don't want to mention. They are all examples of queuing or situations where we find ourselves in queues. Okay? Yes. So this diagram actually depicts, you can see that this is just the ATM machine case over here. It depicts a single server because all these people are in the waiting line, okay, and the server is actually this ATM machine. So we assume that once you get service or you are being served, you exit the system. So these three people at the right hand side have already been served and they've exited. Okay, yes. So in the system, so the system actually has 1, 2, 3, 4, 5, 6 people. That is, there are 6 people in the system. Okay, yes, but in service we have one person. So the number of people who are to be served at a time will depend on the number of service. So the queue length is going to be 5 plus the service length. The service length is the customer being served by the ATM machine. So when you add the queue length plus the service length, you're supposed to get a system length. So in total, we have 6 people in service, in the system, sorry, but one person is in service and the remaining 5 are in the queue. Okay, usually we don't apply queuing theory to only human beings. Okay, so we term it as either a customer or an element. So an element, for instance, if a machine a machine is parceling product in a company or in a manufacturing company, the elements are supposed to be kept in a queue so that the machine will pack or maybe arrange or like package them in a random order. Okay. For instance, for those of you who know pure water manufacturing companies, you see they always have this kind of rule, like a rubber rule, such that when the machine cuts one sachet water, the remaining one, the follow up one automatically kills him. So that's like a queuing system. Okay. But these are not human beings. They are elements. They're just normal elements, like goose. Alright? Yeah, so we can term the elements or the customers to be our arrivals. Okay, those are the arrivals. So the arrivals can either be elements or they can be what customers. All right. Yeah. So let's look at some classifications of QA models. Okay. So most elementary QA models assume that the inputs or arrivals and outputs or departures follow birth and death processes. Depending on the nature of input and service, there can be what? A number of QA models as shown below. So the first one is a probabilistic QA model. So remember, in every queuing system, we're supposed to have elements or customers arriving, and after they arrive, they are expected to be served. Okay, so now we have to assume a distribution for the arrival rate and the service rate. Okay, so as the name goes, a probabilistic queuing model is one where the arrival rate distribution and the service rate distributions are unknown. They follow some unknown random variables. So we cannot say arrivals follow Poisson and then the service time follows exponential or any other continuous distribution. This in a probabilistic queue model that is not known. But in the case of a deterministic queue model, both the arrival and the service rate distributions are known and fixed. It means we can assume some particular distribution for these. Okay. In a mixed queue model, as the name goes, it's a vice versa process. So it's either the arrival rate is known and the service rate is not known, or the vice versa. Okay. Yes. So let's look at some characteristics of a queuing system. So when we say characteristics of a queuing system, what we are simply trying to say is we know that there exist queues that we form every day. What are the things that are most important to learn about these queuing systems or queuing models? And that is what the characteristics are. So we normally want to know the input process or the arrival pattern. So what manner do our customers or elements arrive into the system? And what is the service mechanism or the service pattern? And the third is the key discipline. I'll break all these into pieces, like into details for you to understand further. So when we talk about the input process, it refers to how customers arrive and enter the system. So typically, customers arrivals occur in a random and unpredictable manner. Okay, as the customers act independently as they arrive into a system or an organization, and we have no control over their behavior. You get it? So the input process, when we talk about it, we simply want to know the size of arrival, as in how many people join the queue at a point in time, right? And the inter-arrival time, as in between Kwajo and Kwaku's arrival, what is the time between that arrival? So is it that every 5 minutes we receive a customer, or every 2 minutes, or every 10 minutes, and so forth? That is the inter-arrival time. So the time between the arrival of the successive customers and the capacity of the system. Capacity, we want to know like how many. For instance, if I go to the MTN office, like, and there are 50 chairs over there, it means that the capacity of the system or that space they have is 50. That's the capacity of the system. All right. Yes. So if the capacity, this is very important because we need to know so that we don't have to keep other customers waiting outside so that they will lose patience and leave. For instance, let's say that you go to the MTN office or the bank, and the room, the bank hall is full. Some customers are standing outside. They are exposed to the sun and there's no space for them to sit. There's no customer that can wait over there for more than 50 minutes or 1 hour. So they will definitely leave, or maybe 30 minutes they will leave. Okay. So it's very important to know the capacity of our service system. Okay. And the customer behavior. We need to know like, what is the behavior of the customer. So some customers are there. You see, when they join a queue, for instance, if we have multiple queues at the system, they may leave the longer one to join the shorter one. Others too are there. When they see the length of the queue, they do not want to join at all because it's so long and they exit. Yes. So this customer behavior looks at that. We look at all this into details, right? Yeah. So let's move on. These are just what we want to talk about under the input process. Okay. So when you look at the arrival pattern or the input process, you can see this flow chart over here. So it's the nature of arrival, the capacity of the system, the customer behavior. We have a lot of types for this. Like each of them has its own breakdown. Okay, so let's move down. So size of arrival, I've already explained this. So we want to know the population. Is it finite or infinite? Right? Yeah. Is the population infinite? And the interarrival time, we've looked at this. The time, the period between the arrival of individual customers. Okay. The capacity of the system. Yeah. So in the queuing context, the capacity refers to the space available for arrivals to wait before being served, like I said. So customer behavior. So the length of the queue or the waiting time of a customer or the idle time of the customer mostly depends on the behavior of the customer. So here behavior refers to the impatience of a customer during the stay in the line. So let's look at types of customer behavior. So the first one is barking. So barking customers are those that do not like to join the queue, seeing the length of it. So once they see that the queue is long, they don't even want to join it. Maybe I'm busy, like I have some other things to do during the day, so I cannot join this queue. They leave. These are barking customers. The next is reneging. Okay, so for reneging customers, they join the queue for some time, they lose patience, maybe after some minutes or a couple of hours, then they exit the queue. So these are reneging customers. The next is collusion. So collusion actually, in collusion, a single customer represents a group of customers. Okay, represents a group of customers, and then, like, for instance, in a situation where we can see collusion, is maybe a household, a father can represent his family for something. Maybe if you go and join a queue for all of them. All right. Yeah. So the idea is that a customer, one person represents a group of customers. That's in collusion. And over here, the service time is going to be longer because that same person to be served requires a lot of time because he's not representing himself alone. Or maybe a CEO has gone for a meeting on behalf of his company, and there are a lot of issues. Maybe he has represented a lot of people. Yeah. So the next is joking. So for um, joking customers, they normally join the queue, but they after some time they realize that, oh, this length is so long, so they exit the longer queue to join the shorter one. For instance, cars in the traffic light. You see, mostly when you observe the way cars move in the traffic light, sometimes when they are always maneuvering. When they see a shorter way to escape traffic or congestion, you see them maneuvering and moving like that. Or maybe sometimes when you see this 2M Express buses on the Kumasi Accra highway, you see the way they maneuver the car through every single space they see. They are behaving, they are actually behaving the concept of joking. All right. Yeah. So let's look at the service mechanism. So the way a service facility is arranged to receive the arriving customer is what we call the service mechanism. Okay. Yeah. So this is a flow chart for the service mechanism, but let's look deep into it. So we have two categories of the service mechanism. That's the first one, service facility design. And with service facility design, I think I'll break this down into for you. And the Q discipline or service discipline. Let me move down to explain. So for service facility design, we can either have a single channel queues, but as in single channel, meaning we have one queue available. Okay. Yeah. There's only one single unit to serve the customer. That's a single queue. We can also have multiple channel queues. That means the queues in the bank or the MTN office or wherever you find yourself are actually a lot. So that's the service facility design. The number of length or queues we form to receive the customer. Then the next is the service of the queue discipline. So here we want to look at the way in which the customers are called to serve, right? So is it that there's first in, first out, or first come first served basis? Is that how our system is operating? Once you come, we consider the person who came first, then we serve you accordingly. So that, or is it that it's a last in first out system, right? Yeah. So in the first in first out, there's no bias in this kind of system as we can all see. So last come first serve. This one does not actually appear in a queue where human beings are involved. For instance, they mostly um, are common in inventory system that you sell stock. For instance, let's say you sell rice, and then maybe you have 100 bags of this rice. Maybe they brought with the same expiry date, and a customer has come to buy 10 of them. Of course, those that have come first to be packed in the shop will be those by the wall or maybe by the extreme end. Okay, so we cannot say that because a customer needs 10 and those we packed first are at the extreme, but we bring all the 100 or the first 90 out and go and pick those 10 at the extreme bottom. All right. So in that case, we are actually serving our first in by last in by first out. Okay, or last come first serve. So it happens in inventory system. All right. So service in random order, like the name suggests, it means we are serving customers in any random order, and this happens not in the industrial or the business system, but in religious organization, right? Yeah, in religious organization, this happens. The last one is service by priority. So here, let's say you go to the hospital and then somebody has just been rushed with cold blood and everything inside, like the customer has just arrived almost at the verge of dying. There's no way they're going to attend to you, those who have breath and you can even still move around and you have still have life. They are going to attend to the person. Though the person has just come, they're going to serve the person first. That's service by priority. Or sometimes when you go to bank, we have in business system that all customers are not the same. There are some customers in a bank, maybe when they come and they need service, they're going to provide to them no matter how. That's service by priority. Yeah, some big man come to the bank. Some of them may not even come to the bank, but they will serve them because they have a lot of money at the bank. And you can't blame the bank too because that is customer service. Yeah, because that one customer, his money alone can be more than 10 customers in that bank or maybe 20. Okay, so we end our video here on this the introduction. This is just an introduction to TV model. So in our next video, we'll look at CD and transient state. Thank you so much for watching and God bless you. God bless you.